Hello everyone, welcome to day 3 from week 7. Hopefully you had a good week. I apologize again for having to cancel class. Like I told you before, I will be out of town actually on Friday and Monday. So I know if you try to get a hold of me, you'll have to be patient. So I'm trying to wrap up all those loose ends today. So um, your last actual assignment that is due before, in order to gain that extra credit, is 7.16. We'll talk about that at the end of the recording. But let's go through some review topics. Now, Friday's lesson actually is a review for the test that we're taking the Monday after spring break. Now, I am probably going to, no, I know for sure I will be going through a lot of this again on Monday we come back. I just wanted you, if you so choose, to have all the information now, that way you can work ahead and take the test. Since we just spent the last 2 weeks learning all this stuff, to not use it for a week, you may lose some of it. So I wanted to give you the best opportunity possible. So these are the things we're going to be looking at today, and then again we'll look at them in Monday when we return from spring break. So the first thing that we're going to be looking at is congruence. So all congruence means is that you have the same exact size, shape. So everything has to be the exact same size. The angles are the same measure, the side lengths are the same measure, and it has to be the same shape. So you can see here that on the top 4 triangles, we have a variety of different triangles. This one is obviously not congruent to anything else because it's smaller than the others. So if we're looking at them, then we have to make a decision. Hopefully you're thinking to yourself, the 2 left triangles are actually the same and they are congruent, even though they're flipped in different directions. They still are congruent because they're the exact same size and shape. This triangle is a different type of triangle altogether. The bottom 2 triangles would also be congruent, and that's maybe a little bit more clear. Again, they're just flipped in a different position, but you can see they both have those right angles. Their side measures, their heights are the same, their lengths are the same, and you can see that it's the same type of triangle. All those sames tells us that these are congruent. So congruency has to do with everything being the same measurement. We also talked about angle pairs. Now, we talked about 4 different main types of angle pairs. The first one we actually talked about was adjacent. And adjacent meant they are next to each other. So you can see that angle A and angle B are next to each other because, first of all, they're next to each other, but they also share, they also share this exact same line here. So they have to share one of the same rays in order to be adjacent. If we're talking about vertical, that means they're going to be, so here we'll write adjacent is next to, vertical is across from. So if we're looking at angle B, it's across from angle C. Angle A is across from angle D. Angle F is across from angle G, and angle E and H are across from each other. These all angles are also always going to be congruent. Vertical angles will always be congruent, meaning they'll have that same exact angle measurement. All right, then we also talked about complementary and supplementary. Complementary meant angles that added to 90 degrees, and supplementary meant they added to 180 degrees. So if we have an angle over here, you can see it adds to 90 degrees because there's that little 90-degree box symbol in the bottom. So if this side were 60, this side has to be 90 in order to get that. I'm sorry, it has to be 30 in order to be 90. If I try again, I also could say, well, maybe it's 55, so this would have to be 35. 55 plus 35 is going to give us that 90. The angle to the right, those would be supplementary, so maybe now this is 120, so this has to be 60. Or maybe it's 110, so this has to be 70. Again, no matter how that angle changes, what the exact measurement is, they're still adding to 180, so these would be supplementary. Then we talked about triangles. So we talked about, in the past, we've talked about acute or equilateral, isosceles, and scalene. Equilateral meant all three sides are congruent. Isosceles meant two sides are congruent. And scalene meant no sides are congruent. So all three of those sides are a different measure. We also, this chapter then talked about acute, right, and obtuse triangles. Acute meant all three angles are less than 90 degrees. So we couldn't have any 90-degree angles in there. If we had a right triangle, we had exactly one 90-degree angle. And if we had an obtuse triangle, we had one angle that was greater than 90 degrees. We can't have more than one angle greater than 90 degrees because all triangles have to equal 180 degrees. And if we had two angles that were greater than 90, then the third triangle measurement wouldn't have one. So we talked about how to find that third measurement. We said add the two that you're given. So if I had 60 plus 40, that got me 100. I could then take 180 because all triangles are 180 and subtract the 100 in order to get that 80 degrees. Again, add the two that you're given. So I'd have 90 plus 45 and I'd get 135. So that other angle would have to be 45 degrees because you take 180 minus 135 to get 45. On this triangle on the very right here, it looks kind of complicated, but that's only because there's two questions that are being asked. First, we want to know what the measure of angle 1 is. Then we want to know what the measure of angle 2 is. So first we'd add these up, so I'd get 30 and 42. I add them and I get 72. That tells me that the measure of angle 1 would be 108 degrees because 180 minus 72 gives me 108. Then I could do the same thing and I could say, well, this is also a supplementary. So if this angle 1 is 108, then angle 2 has to be 72 because they're supplementary, so they're going to add to 180 degrees. So again, 180 degrees is that big ticket number we're looking at when we're talking about triangles. We also talked about what to do if we are forming triangles. How can we form a triangle if we only know their side measures? Well, that was when we had to add them up. So we added two of the sides to see if it was bigger than the third side. And if it was bigger than the third side, every single time we added, it would work. So I'm going to start with the two smaller sides. So I do 3 plus 4 equals 7. And 7 is bigger than my 5. So far we're doing good. But now I need to go try two different side measures. So now I'm going to try adding 4 and 5. So if I add 4 and 5, that gets me 9. And we want to see if it's bigger than 3. Well, that also works. So far we've got 2 out of the 3. Then we need to try the last one. So we're going to add 3 and 5 and see if it's bigger than 4. So 3 plus 5, I get 8. And then we want to determine if it's bigger than the 4, which it is. So then this tells us this could form a triangle. I could draw a triangle, so you could say, yes, this is a triangle. And we'd be happy with that. Let's try another one. So now I have 6 and 8. So I do 6 plus 8 gives me 14. And I want to figure out if 14 is bigger than 22, which it's not. Uh-oh. This is bad. All that means is no, this is not a triangle. As soon as you find one of those 3 addition facts, doesn't matter which one, we lucked out that it was the first one we tried. But had we gone through the whole set and found that one of them went through and 2 of the other ones worked, it doesn't matter. If one of them fails, it's not a triangle. It will not work. Then we talked about polygons. So polygon had 3 very specific definitions. They all had to be straight sides, so no curves. They had to be closed, so no openings. And every point only touches 2 other endpoints. So if we look at our examples on the bottom, I'm I'm going to actually start with the not polygons first. So you can see that this has a curve, this has a curve, this has a curve, and that has a curve. So right away that tells us no polygons. Then we have to go and think about, okay, which ones are closed? Well, first of all, that one's not closed. You can see that amongst that curl, here, let me erase those, amongst that curl there's an opening. Well, then the triangle next to it also has an opening. So, nope, these are not. And then we have to think about every point only touches two other endpoints. Well, if I put a dot right here on this X-looking figure, you can see that it crosses this line one time, and then this line one time, and then this one, and then this one. And that's actually 4 lines. So that doesn't work because it only can be 2. So all of those would be not polygons. Sometimes it's easier to look at what's not a polygon than it is to look at what is a polygon. The other 2 shapes are a polygon. They both have all straight lines. They both are closed. There's no openings. And every point only touches one other point. So if I draw a top of my triangle, it only touches this line and this line. And no matter where I go on that triangle, it's going to be true. So if I go to a different point, let's say I go this one, it's only going to cross 1, 2. If I do it to the last one, again, it only crosses 1, 2 times. So just know the difference, practice the difference between what is a polygon and what is not. Then the topics that we covered this week were area and circumference of a circle. So we talked about the song pi r squared sounds like area to me. Yeah, that's a good one to get stuck in your head, just to warn you. It gets in mine all the time. So if we're looking for the area of our circus is taking our pi times our radius squared. Remember, our pi can come in 3 different forms. It can come in the symbol, and that symbol is used to represent that whole long decimal that we can't actually calculate. Or we can use the decimal that we can get close to, so we just round it. Or we can look at the fraction. Now, we didn't work much with the fraction, but do know that it was an option. So the area, we looked at the radius, and the circumference, we looked at the diameter. And just to throw this out there, remember the radius and the diameter have that special relationship where if my diameter is 8, my radius is 9. They're always 1.5 of each other. So if my radius is 4, then my diameter is 8 because we're looking for 2 parts to that whole. So in order to find the area of my circle on the bottom, I would take my radius, which is 5, and I'd square it and times it by pi. Oops. So 5 squared, I'd get 25. 25 times pi would be my exact answer. If I wanted to use that decimal, I'd do 5 squared times 3.14, and I'd get 25 times 3.14, and I think I get about 78 or so. Close to that. I don't have my calculator offhand. If I wanted to find my circumference, then we need my diameter. So in this case, if my radius were 5, my diameter is 10 because we're looking at that whole piece there. So then I do 10 times pi. So I could use the exact symbol to do 10 times pi, 10 pi, or I could do 10 times 3.14 to get 31.4. Close to it. All right, the last thing that we looked at on Wednesday then was the volume of the cylinder. And that volume of the cylinder was important because first we had to find that area of the circle and then multiply it by our height. Remember, that is our area of our circle. So first we found the area of our circle. So we would do 4 squared. I don't know why that keeps happening. I apologize. 4 squared times pi, and I'd get 16 pi. So that's the area of my circle, and then I multiply it by my height, which in this case is 15. So if you wanted to get your main answer, you do 16 times 5. All right, so today we went through a review. Your choice when you complete the test. You can complete it over spring break, or you can wait till Monday. You need to be up to 7.16 to get the extra credit. Anything that has an EX in your grade does not count. That does not mean it's missing. You don't have to finish it. Your mystery numbers today will be 8 and 7. And I will put the zeros in the schedule up though next weekend, not this weekend. I'll give you as much time as possible to work on all of this stuff. Have a great week.